Here we are going to talk about lines of symmetry and rotational symmetry. Let's first define what is lines of symmetry. Lines of symmetry is generally asked for a polygon, how many lines are there and how many lines can be drawn across a shape in such a way that the folded part can sit perfectly on top of the other. So it is effectively a mirror image that we are looking for. Let's take a quick look. For a square, if I draw a line of symmetry like this, the shape over here, when I fold it, it can sit very easily on this side, right? Effectively, this is the mirror image of this. Similarly, for the same square, there can be a line of symmetry like this as well. When I fold this one below or this one to the top, both of them can sit on one top of the other. Similarly, I can actually draw for a square a diagonal like this or a diagonal like this, and both of them can be mirror images to each other. So altogether, for a square, there are 4 lines of symmetry. One vertical, second horizontal, and the third and fourth which are diagonal. So for regular polygons, we do have how many ever number of shapes there are. It is those many number of lines of symmetry you typically will have. So if we take a regular pentagon, so we can actually draw so 5 lines like this, and for a pentagon there are 5 lines of symmetry. What about a rectangle? Let's take a look. A rectangle, if we take a look, we can draw 2 of them. It's not a regular shape. Okay, so if we draw a line like this, if we fold it, this will actually come on here, right? Will it fold properly? Not really, and hence it only has 2 lines of symmetry. Okay. What about a parallelogram? Let's take a look. Parallelogram also falls under the same category. As similar to a rectangle, we generally think, okay, I will draw a diagonal line, and if I fold it, it will actually sit on. No, it will not. It will actually come here. So when we fold it, it will be folded something like this, and it will not be coming on top of the other. Okay. However, for a rhombus, that is the case. For a rhombus, all the 4 sides are equal, and when we actually have something like this or something like this, it actually has 2 lines of symmetry for a rhombus. What about a trapezium? Trapezium has 1 line of symmetry. What about a kite? Kite also have 1 line of symmetry. Okay. What about an equilateral triangle? Equilateral triangle will actually have 3 lines of symmetry. What about an isosceles triangle? Isosceles triangle will have one line of symmetry. There are other shapes, for example, a heart shape, it has 1 line of symmetry, and so on and so forth. Let's take a look at rotational symmetry. Whenever a shape is rotated, it should look exactly the same. That is effectively the rotational symmetry. Now, generally in an exam, you would be asked, what is the order of rotational symmetry? Yeah, that's what you would be asked for. Which means, if I take a shape, let us take an equilateral triangle. An equilateral triangle, when I move it anti-clockwise or clockwise, it can be moved. Say for example, I have the top, this can go to the bottom, but still the shape can look like the same. This can go to the top and then this can come again. So if I rotate this in a 360 degrees, how many times would it look alike? 1, 2, and 3. And hence the rotational symmetry, the order of rotational symmetry for an equilateral triangle is 3. However, for, let's take an isosceles triangle like this, or an isosceles right angle triangle like this. What happens if I rotate if I rotate this one into any way or shape? So it will actually become like this, and this will go like this, and again it will become like this, right? So 1, 2, 3. The third time it is actually becoming similar to what we have the original one, right? So, and hence the order of symmetry is 1 over here, because in all the, across all the 360 degrees that we rotate, only this is looking like the original one. Now, if we take a star like this, okay, and if I have this side, and if I try to rotate again, this can actually come here and it can look exactly the same. So excuse me for my drawing skills, but if you rotate like this, it can be rotated 1, 2, 3, 4, 5 times like this, right? And it can still look the same. Hence the order of rotational symmetry for a star shape is 5. What about for a parallelogram? For a parallelogram or a rhombus, so if I rotate for a parallelogram, in a total of 180 degrees, it can look alike twice like this. Okay, so the order of symmetry for a parallelogram is 2. And the same case is for a rhombus as well. What about for a shape like this? For a shape like this, the lines of symmetry should be 1. And the rotational symmetry, it can only happen again, however times you rotate in 360 degrees, it will come back to its original shape only once, and hence it has 1 order of rotational symmetry. What about for a shape like this? If you observe carefully, there's an equilateral triangle, and at the same time for each equilateral triangle, at each side you have an arrow which is exactly similar. So if you rotate this for every 120 degrees, it will still be the same. If I rotate this to 120 degrees, it will come like this again, and again if I rotate it again, okay, this would come here and this would come here. Still the inside arrows would look the same way, isn't it? So the order of symmetry for this is 3, because we have 1, 2, and 3 similar shapes to that of the original one. I hope you got a better clarity on line symmetry and rotational symmetry with this video. That's all for today, and happy learning.